Okay, so the paper is May-June 2015 and its variant is 2-2. AS paper. Look at the question number 1. Use the definition of the work done to show that the SI base unit of energy are kilogram meter square second power minus 2. So look, energy is equal to work. And the definition of the work is, it is the product of force and distance. Force is measured from MA, so MA into D. Now the mass is measured in kilogram, acceleration in meter per second square, and the distance meter, so final unit kilogram, meter square, this and second power minus 2, hence it is proved. So we have to write these 3 lines. Next, define potential difference. So the definition is work done per unit charge to convert electric energy into other form of energy. Other form can be rotational kinetic energy, mean mechanical energy, light energy, heat energy. Next, determine the SI base unit of the resistance show you're working. So the resistance, according to Ohm's law, V is equal to IR, R is equal to V over I. And this V potential is the work done per unit charge into current. The work is F into D. Charge is IT and into I. Now this F into D, we have done this. It is kilogram meter square second power minus 2. Current into current, this ampere square second. So the final shape will be kilogram meter square second power minus 3. When this comes up, it becomes second power minus 3. And this comes up, it becomes a power minus 2. So here we have to write kilogram meter square second power minus 3 ampere power minus 2. So this is the C part. Now look at this question number 2. A stone is thrown vertically upwards. The variation with time t of the displacement s of the stone is shown. This is displacement time graph, not the speed time, not the velocity time. Use the figure 2.1 to describe without calculation the speed of the stone from time 0 to time 3 seconds. Look, the gradient of this graph is the velocity. So here the gradient is maximum at this point. Here the gradient becomes 0 and then gradient increases but in the opposite direction. So we will write it is thrown up with some speed which decreases gradually at, look here, this point, this one is approximately 1.25 at 1.25 second, it is 0, then increases in the opposite direction. So here is some speed. It becomes 0 at the top because the gradient at the turning point of displacement time will be 0. And then it increases after this time, but in the opposite direction because the gradient is negative. Now the question is, B part, assume air resistance is negligible and therefore the stone has constant acceleration, mean 9.81. Calculate for the stone the speed at 3 seconds. Look, this speed is required. Now we use this portion of the graph, this one. Look, for this portion, this initial speed is 0, and the time taken from this 1.25 to 3 minus 1.25, it's 7.5 meter, and the final speed here required. So we can write V is equal to U plus AT for the second part of the graph. The final velocity is required. Initial velocity for this part is 0, acceleration 9.81, and for this part, the time is 3 minus 1.25, mean 1.75. So we have to calculate this, and it is approximately 17.2 meter per second. So for this part, you have to consider only this motion, which is downward. Initially, the stone, the object is thrown up, it reaches at the top, and then it goes down, it falls down. So 0 time, 1.25 second, and 3 second, mean this downfall is 1.75 second time. So we have to use only this portion. Now the next part is the distance traveled from T0 to T3, means 0 to. So both portions, first up and down. So first we have to calculate the distance for this upward motion. If we consider downward motion, so initial speed at the top is 0. The distance covered is required. So first we will calculate this distance, which is covered upward. S is equal to UT plus 1 by 2 AT square. So distance required, if it is considered downward motion, for the downward speed is 0, 1 by 2, acceleration 9.81, and the time taken for this part is 1.25 square. So this distance after the calculation is equal to 7.66 meter. And after this, we have to calculate this next distance, next portion distance again. S is equal to UT plus 1 by 2 AT square. So the distance, again, at the top here, the initial speed 0, 1 by 2, 9.81, and the time here is 1.75 square. So after the calculation, this is coming approximately 15.02 second, but we have to write here the total distance. So the total distance will be 7.66 plus 15.02, and it is approximately 22.7, which can be written as 23 meter. So this is the part here. Next, the displacement between 0 and 3 required. Look at this. Displacement. It starts its journey from this point. It goes up and then down. So this is the starting point. This is the ending point. So the distance between starting and ending point, this one is the displacement. This is the displacement. The gap between starting and ending point. And this will be 15.02 minus 7.66, and it is approximately 7.4 meter. So the displacement is 7.4 and the direction is required, so definitely downward. So we will write here, this is 7.4 and this displacement is downward. If we move to this C part, draw the variation with time t of the velocity of the stone from t0 to t3. So at 0, here, what is the speed? Again, we will calculate from this portion. Look, distance is calculated here, which is 7.66. We can apply equation. V is equal to U plus AT. The final velocity at the top is 0. initial speed is required. And for the upward journey, this is 9.81 minus, and the time taken is 1.25. And then this U is equal to 9.81 multiplied by 1.25. So this is the calculation. So we calculate this 9.81 multiplied by 1.25. It is approximately 12.3. So on the graph here, the scale at the y-axis, this is 10, this is 20, this is minus 10, this is minus 20, minus 30. And at the start, the speed is 12.3. So 11, 12, and 12.3. But the speed at 1.25, it becomes 0. So this is the point. And then the gradient is constant, acceleration constant. So we have to join these 2 points. So this is a graph. So this speed is 12.3, and here the speed becomes 0. Acceleration is the gradient, which is 9.81 constant for upward and downward motion. So this is the graph. You have to draw it with a straight line. Now, question number 3. A rod PQ is attached at the P to the vertical wall. The length of the rod is 1.60 meter. The weight of the rod x 0.64 meter from the P. The rod is kept horizontal and in the equilibrium by the wire attached to Q. The wire provides the force F on the rod, 44 Newton at 30 degree to the horizontal. The question is determine the vertical component of the F's. So we will write here Fy is equal to F sine theta. F is 44 sine of 30 degree. So it becomes 22 Newton. Then the horizontal component mean Fx is equal to F cos theta. So it is 44 into cos of 30 degree. So 44 multiplied by cos of 30. This is approximately 38.1. So we will write it 38. By taking moment about P, determine the weight of the rod W. So I solve this over here. So look, this is the pivot. One force is trying to rotate in the clockwise direction. This F has two components. One is Fx, which is passing through the pivot. It has no turning effect. Other has Fy. Other is Fy, so it is trying to rotate anti-clockwise. So according to law of conservation of the moment, the principle of the moment, look, F1 D1 is equal to F2 D2. So F1 is Fy, which is equal to 22. Its distance from the pivot will be 0.64 plus 0.96. We have to add these two distances from the pivot. So F2W is required, and its distance from the pivot is just 0.64. So after the calculations, W is 22 multiplied by 1.60 divided by 0.64, and the weight is 55 Newton, because this force is required. So this weight is 55 Newton. Now the next part is explain why the wall must exert a force on the rod P. Look at the diagram. For the equilibrium, sum of upward forces must be equal to the sum of downward forces, and sum of left must be equal to sum of the right. Now look, this Fy is 22, and this is 55. Look, downward force is greater than the upward force. And the left side force, Fx, is 38, and there is no force at the left. So it means with the help of this F and W, it's not equilibrium. But Here is written it's equilibrium. It means a third force is also exerted at P to make upward downward forces equal, to make left and right forces equal. For the equilibrium, upward forces must be equal to downward forces, upward and downward not equal. Hence, a force is exerted at the point P. This is the answer. So next, draw an arrow to represent the force acting at the rod at P. So we have to draw the direction according to the principle, according to the rule. If the forces are non-parallel and the object is in equilibrium, then all forces must meet at a point. So this is the meeting point of the weight line and the force. Hence, the force at the P must be passing through this common point. So this is the direction of the force. Now move to the next question. The question is, a gas molecule has a mass of 6.64 in 10 power minus 27 kg. At a speed of 1250, the molecule collides normally with the flat surface and rebound with the same speed. Calculate the change of momentum. So the change of momentum is equal to mass time change of velocity. If this is the initial speed, this is the final speed, but in the opposite direction, velocity. So velocity is direction, has direction, it's a vector. So we will write here minus v minus u. So the mass is 6.64 into 10 power minus 27. The final speed is 1250 minus, and the initial is 1250. So the answer is approximately 1.66 into 10 power minus 23. Now use the kinetic model to explain the pressure exerted. The answer is molecules collide with walls of the container. Due to collision, there is a change of momentum. Rate of change of momentum causes force, and the force exerted per unit area develops the pressure. So we have to write first, molecules collide with the wall of the container. During collision, they change their momentum. Rate of change of momentum causes force. The change of momentum is F into T. And force experience, force exerted per unit area of the wall develops, causes the pressure. Next, explain the effect and increase in the density at the constant temperature on the pressure of the gas. Look, when density increases, it means in the same volume, more mass, more number of the molecules. Or when the volume decreases, so the concentration of the molecule increases. In both cases, when the density increases, either by increasing the mass or by decreasing the volume, number of the molecules, number of the collisions per unit time increases, hence pressure increases. When density increases, number of the collisions per unit time increases, thus the pressure increases. Next question is, on the figure, sketch the temperature characteristics of the thermistor. Look, initially at zero temperature, its resistance is maximum and it gradually decreases. So we have to leave the graph curved, no straight line, not touching the x-axis. And this is also called NTC, negative temperature coefficient graph. Now, the next question is, a potential divider is a circuit shown. The battery of the electromotive force, 12 volt, and negligible internal resistance is connected in series with X, Y, and Z. Resistance Y is 15 kilo ohm, and resistance Z at particular temperature 3 kilo ohm. The potential difference of Y is 8. Explain why the power transformed into the battery equal to the total power. Look, there is no internal resistance, no power loss. So input power is exactly equal to the output power. So the answer is there is no internal resistance. That's why output power exactly equal to the input power. And the next, calculate the current in the circuit. This is series combination. So the current remains same. Look, the resistance of Y given and the voltage of Y given. So we will write V is equal to IR. So V is 8, I required, and this is 15 kilo, mean 15,000. So I is equal to 8 divided by 15,000. And the answer is 0.53 into 10 power minus 3 ampere, mean 0.53 milliampere. Calculate the resistance of X. Look, this is series. We can apply Kirchhoff's second law. EMF is equal to current and the sum of the resistors X plus Y plus Z. So EMF provided is 12. Current is calculated 0.53 into 10 power minus 3. And then X is required. The resistance of the Y is 15,000 and the resistance of the Z is given 3,000. So after the calculation, we can calculate this. 12 divided by 0.53 into 10 power minus 3 is equal to X plus 18,000, and then X will be equal to approximately, it is 4.52 into 10 power 3 ohm, mean 4.52 kilo ohm. And the next question is, the temperature of the Z is increased. State and explain the effect on the potential difference across Z. Look, if the temperature of this thermistor increases, its resistance decreases, the current in the circuit increases, but the potential across this Z will decrease because in series, voltage is directly proportional to R. So when temperature increases, resistance decreases, hence potential decreases. So we have to write over here. Now the next question is, state two differences between the progressive wave and the stationary wave. Look, the progressive wave has net transfer of energy, but in stationary wave, there is no net transfer of energy. In a progressive wave, no particle is permanently at rest, but in the stationary wave, the particles are stationary at nodes. In progressive wave, no two particles are in phase, but in the stationary wave, within one loop, two particles are in phase. So these are the differences between progressive and stationary wave. Now the next is, a microwave detector D is placed between the R and S. Describe how stationary wave are formed between R and S. Stationary waves are formed between R and S. Look, incident wave, the wave is emitted from the microwave. It travels towards the reflector. The incident wave is reflected back. Both are traveling with the same frequency, same speed, but in the opposite direction. They overlap each other. The overlapping causes the stationary wave because nodes and antinodes are formed. Next is how D is used to show that the stationary wave are formed between R and S. Look, when the detector is moved between S and R, there will be continuously minimum and the maximum reading on the display of the detector. Minimum and maximum mean nodes and antinodes are formed. So if there are continuously in minimum and maximum reading, it means stationary waves are formed. How the wavelength of the microwave may be determined using the operators. Measure the distance between two either minimum reading or to maximum reading, and that is the distance between node to node or antinode to node. By multiplying that distance by 2, the lambda can be determined, because node to node the distance is lambda by 2. So the lambda will be the distance multiplied by 2. The question is, the wavelength of the microwave is 2.8. Calculate the frequency in gigahertz of the microwave. So V is equal to F lambda. F is equal to V divided by lambda. Microwave is the electromagnetic wave, so its speed is 3.0 into 10 power 8, means speed of light, divided by wavelength is 2.8 into 10 power minus 2, because centimeter converted into meter. Now, after the calculation, this is approximately 10.7 giga, 10 power 9. So we can write it into significant figure 11 gigahertz. Now the next question is, a uranium-235 nucleus absorbs a neutron and then splits into two nuclei. A possible nuclear reaction is given by uranium-92-235 plus neutron. Look, neutron has numbers 0 down and 1 up. No charge, but has mass. And similarly here, this is 0 and this is 1. State the constituent particles of the uranium-235. Look, 92 protons in the uranium are 92 and neutrons are 235 minus 92. So the answer will be 143. So 143 protons, 143 neutrons and 92 protons. Next, complete the table. So look, this B is 0 and this A is 1. Now we have to calculate C and D. So the charge is conserved. Mass is conserved. For the mass, we can write, look, this side is 235 plus 1. This is 236. And this side is 93 plus C plus 2 neutrons. It becomes 2. So 236 minus 93 minus 2, 95. And this is the C. And it is approximately, this is 236 minus 95, it is 141. Now the charges are conserved. The charges are 92 because 92 and 0, 92. This is 37. This is 0. So 92 minus 37, D will be the answer. So 92 minus 37, it is 55. Now suggest a possible form of the energy release in this reaction. The kinetic energy of the product particles like this X, rubidium, neutron, or we can write the energy is released in gamma rays, photon, or in the gamma radiation. Either write the kinetic energy of the product particle or energy is released in the gamma radiation or gamma rays, photon. The next part is explain using the law of mass energy conservation how energy is released in this reaction. Look, the total mass of the left side and the total mass of the right side not equal. When the masses are calculated and compare, the total masses left and right not equal. The difference of the mass is converted into energy, which is released according to the famous equation, E is equal to mc square. So first we have to write the left side mass not equal to the right side. This difference of the mass is converted into energy according to the relation E is equal to mc square. So this is the paper.